All right, this is Algebra 2, the last video talking about transformations, and it's going to be writing the equation for the new transformed equation. So what we need to look at is first, let's look at the graph. Given from a graph, how can I write a transformation? Well, first thing, let's think about, well, parent graph. So number one there, what's my parent graph there? Well, it's a parabola. So my parent graph is going to be f of x equals x squared. Now we have to always remember our starting point when our parent graph is at 0, 0. So we know that this couple things are happening here. It's moving to the right 3 places. We know it's moving to the right 3, and it's also moving up 3. So it's moving right 3 and up 3. Now we have to look, is it being stretched, shrunk, flipped, anything like that? Well, it's facing up, so we know it's not being flipped over the x-axis. It's kind of hard to see if it's flipped over the y-axis, so we're not going to worry about that. Now we have to look, does it go from our points? Normally, here would be our points there. So does it keep going over 1, up 1? Yeah, our slope is about the same. So the only thing that's happening here is that it's moving right 3 and it's moving up 3. So we have to figure out, well, where does this go outside, inside? Up we know goes outside, right we know goes inside. So let's write this. So we know that f of x is going to equal, now we need to put that right 3 on the inside, so we know it's got to be x, and right we think opposite, so minus 3 when it's on the inside, squared, up plus 3. All right, let's show some more examples here so you guys can get a little hold of it. Parent function. What is our parent graph of this? Well, that's easy. That's f of x equals the absolute value of x. What are all the things that are happening here? So remember, we're starting at 0, 0. That means we need to move left 4 places. Left 4, and we're moving down 1 place. Always make sure we're looking at the scale, and it is going 1 by 1. Now, one thing too is this is opening down. That means that there's a reflection over the x-axis. There's a reflection over x-axis because it's opening down when our absolute values always open up. Now we have to go look, because if it was still opening down this way, our parent function just opening down, it go 1 by 1, and again this goes down 1 over 1. So we're okay. That's all that's happening. Let's look what goes inside, what goes outside. Left, that means it goes inside. Down, that's out. Reflection over the x-axis, that means it's going to be outside. So let's write this. F of x equals, now the reflection, that negative goes outside the absolute value. Inside we have left 4, so really it's x plus 4. And then we're moving down 1, so minus 1. There's our actual function. All right, what's our original parent function for this one? Well, you guys should know this one. It's going to be f of x equals x cubed. Now there's a couple things happening in this thing. First thing is it's moving up, because we usually start here. It's moving up 4 places. Okay, now it's kind of confusing because if I drew my first 3 points of my cube, notice what's happening here. We're actually being flipped. We're reflecting over the y-axis this time. So we're reflecting over the y-axis. We're not moving left or right at all. We're still only going 1 apart, so there's no stretching or shrinking there. So really, that's all we're doing. Up, we know that's outside, and reflection over the y-axis, that's inside. So our function that we're going to write, f of x equals, and it's cubed, so we need to put parentheses, negative x cubed, and we're moving up 4, so it's plus 4. All right, let's try another one here. Now again, we're looking at this. We have a parabola. So if it's a parabola, we know that our parent function is f of x equals x squared. Now we know we usually start at 0, 0, and we go up 1 over 1. We're opening up, so we're not reflecting over the x-axis. We're moving to the left, what is that, 5 places. And we're moving down 5 places. Now we have to look, are we still going over 1, up 1? Yep, we're okay with that. So that's all that's happening. So now we look again, left is inside, down is outside. So f of x equals inside, x left means we're going to go plus 5, squared, and we're going to go down 5 places. All right, I want you guys to try these these three. Let's just start with these first two. Let's start with these two. I want you guys to try on your own. I'll show you guys the answers in a second here. Now, this one's going to be tough, so I'll put up the answer to the last one in a second, but I want to talk about this one. I want you guys to notice that our x's are getting further apart, so that means that it's going to be a horizontal stretch by 2. So make sure you have that horizontal stretch by 2 when you guys are writing your equation. So try to write your equation, and I'll put up the answer here. All right, there are the two answers. Second one, number 6 there, seems pretty easy for you guys. Number 5 is probably more difficult. What you have to make sure you have is parentheses around the x minus 3 there inside of your absolute value. And you're not stretching by 2, so which means you have to multiply the inside by a half. Remember, you have to think opposite. Think opposite. All right, I want you guys to try 2 more of these ones on your own. So try these last 2 here on your own, and I'll put up the answers in a second. All right, so here are the solutions I got for these 2 problems. Notice that there is a vertical stretch on the first one, and there's a vertical and horizontal stretch on the second one there. All right, so now what if I don't give you a graph? What if I just tell you what's going to happen? So now you have to look at this and you have to say, well, what happens to each piece? Well, we know that our parent graph is y equals the square root of x. We have a vertical stretch by a factor of 2. Vertical stretch, that means we're going outside. We shift right 2. Well, that's inside. And we move down 3. Well, again, that's outside. So now all we have to do is fill in the pieces that we know. So we know that y equals, and it's a vertical stretch by a factor of 2. Vertical means it's outside and it stays the same. Multiply that by our x right 2, which means minus 2. And then we're going to move outside is going to be down 3. So there's our answers. We moved a vertical stretch by a factor of 2, we moved right 2, and we moved down 3. Let's try this one. We have a horizontal shrink by a factor of 3, so that means that it's going to be a inside. We shift left 1, so again that's inside, and we move up 2. Well, that's outside. All right, so we know we need to go inside for a lot of this stuff, so y equals inside. So we're moving a shrink of 3, which means we're multiplying by 3. Again, remember, we're multiplying the whole thing, so we need to put parentheses around it. And we're going to move inside left 1. Left 1, that means we need to add 1. Close that, square it. And then we're going to move outside, we're going to move up 2. There's our answer to that. Remember, when you're stretching or shrinking inside, you have to multiply that whole thing. So everything else that's happening inside has to be multiplied by that shrink or stretch. Last one. All right, we're going to reflect over the x-axis. Remember, reflecting over the x-axis is on the outside. We're going to move up 3, which is outside. We're going to have a horizontal stretch by a factor of 4. Well, that's inside. Well, stretch by a factor of 4, remember, that means we're going to divide by a factor of 4. So y is going to equal, we're going to reflect over the x-axis, which means we have to have a negative. We're going to divide by 4 because it's a stretch by a factor of 4, and then we're going to move up 3. All right, that's all we're going to talk about in this video. Make sure you guys ask me if you have any questions. Let me know if you have any. Otherwise, just rewatch the video and pause it where you need to.